Balls. There's nothing more fun. Right in the coffee. Tonight on Going Deep, it's how to bounce a ball. This is a how-to show about things you think you know how to do. Because simple things are more complex than they seem. I'm David Rees. Let's do this.
We're going deep with David Rees.
If you're like me, you were once a child. Back then, the only ways there were to kill time were bounce balls and steal cigarettes. And my favorite ball bounce was the one Steve McQueen did in The Great Escape. Floor, wall, hand. Repeat, floor, wall, hand. Escape from prison. But now I'm a grown-up man, and I have more ambitions for my ball bouncing activities. Imagine that this is the top view of a room with 4 walls. I want to throw my ball from here and have it bounce off all these walls in a super dynamic ball bouncing trajectory, and then fall right back into my hand. Boom. This is what I call a gentleman's ball bouncing experience. By the end of the episode, I should be able to do this, and you should too. If I'm going to manipulate a ball's bounce to my every whim, I need to understand what I'm manipulating. What makes things bounce? What goes on in this illuminated box of balls?
Well, we drop basketballs and we shoot them with high-speed cameras.
This, to me, is wonderful. This is the Physics and Astronomy Department at the University of Pennsylvania, and this is Dr. Robert Johnson. He said I could call him Bob. I've come to you with a very interesting question. What is bouncing?
A bounce is when an object changes its acceleration whenever it collides with another object.
That means if I dropped a ball and it hit the ground and just stopped, that would be a bounce.
Yes, you could call that a bounce. It could bounce back with 0 velocity. It depends a lot on the molecular properties of the surfaces that are interacting. You have atoms that are getting compressed, if you will. The bond between these atoms gets compressed. The electron clouds get closer, which increases the repulsion between them, and so they separate. They bounce off of each other.
When I bounce this ball, are the molecules inside the ball literally bouncing against each other?
They're not physically touching. It's a contact force. Take your hands, right? You push them together.
Right.
So the total force between your 2 hands is the result of all of those little microscopic forces between electrons.
Are you saying your hands aren't actually touching each other?
The electrons in my hands are not actually touching each other.
So if I had the world's most powerful microscope, right? I mean, this is a microscope more powerful than anything we can imagine in our wildest sex fantasies. If I get up really in between your hands, I'm gonna see blank space in between your hands?
That's right.
If I really want to understand what bouncing is, do I have to understand a bunch of stuff about electrons?
It's important because that helps you understand why some objects bounce and why some objects stick and go splat. It's sort of like compressing a spring. Converts that kinetic energy to potential energy, but you get it back. But if you had something like a paintball or Play-Doh, you drop those objects on the ground, they permanently deform and they don't bounce back.
Watch this.
Whenever you drop it, keep your hand at a fixed height.
Don't move my hand after I drop it?
Don't move your hand, and we'll compare how high it goes on the first bounce to wherever you released it.
Okay.
So it got what?
It came to like here.
80%?
That sucks.
Whenever this object collides with the floor, some of that energy is lost as heat, some of it's lost as sound because you can hear the ball bouncing.
Holy shit. So that's where the missing energy goes? Some of it goes into sound?
Yep, and so some of the kinetic energy that this initially had is lost, and you don't get that back.
Some of the energy
That's right.
that could have been put back into this ball, getting right back up where it's supposed to be?
Yep.
And instead I have to listen to dunk. So balls are losing energy every time they collide with the surface. I said, Bob, show me a closer look at this mysterious collision. Use your science camera.
What we're gonna do here is you're gonna hold this ball, and we have this little landing zone marked.
You gotta get a shot of this landing zone. Ready? Here we go. 1, 2, 3. Did I do it?
Yep. So when I press play, you'll be able to see this deformation that happens,
Oh!
and then it springs back into shape.
Okay, is this one of those things that for any given ball that I choose, there's gonna be an optimal surface to throw it against?
Yes.
Is there some way to quantify that?
So there's this parameter called the coefficient of restitution, and that's a measurement of how much energy is lost when 2 surfaces collide.
So I want a coefficient of restitution of 1, which would, if I had that and I dropped my ball, it would come right back up into my hand.
That's right.
So hook me up.
Yeah, I don't know of any material where it really truly is 1.
Oh. To achieve maximum bounce, I need a coefficient of restitution as close to 1 as possible. So which ball has it? You want to hear about a guy who's qualified to speak about ball bouncing? This is author and anthropologist John Fox. He wrote a book called The Ball, and he co-produced a documentary called Bounce. I said, you know we're booking this motherfucker. What do we have here?
This is the most awesome ball on the planet.
Boom. End of section. We're out. Peace. Is this your #1 ball?
This is my #1 ball.
Really?
Yeah.
Speak to me about this ball.
All right, so this is a Spalding. If you grew up in New York City, you would know this ball very well, because this is a ball used on the street for every street game possible.
Okay.
Handball, stick ball, box ball, this ball could do it all.
What distinguishes this ball?
Well, it's made of rubber.
Okay.
Rubber was the game changer for balls. Rubber was invented in Central America, 1500 BC. The Europeans were amazed when they saw rubber for the first time because they'd never seen it before.
Right.
In fact, they thought it was possessed by demons.
Europeans are so dumb. Best ball of all time, according to you, is this ball.
Spalding.
Best ball for my purposes is going to be the one I think that bounces the most.
Right.
John and I agreed to go into scientist mode with each other. We conducted one of the most high-tech ball bouncing experiments of all time. Is the bottom of the ball lined up with the bottom of the tape?
I think so, yeah.
Great. That's what every scientist loves to hear. Here we go. 3, 2, 1. Oh. Soccer balls are officially weak. I want them out of my country. I want my country back. John measured with astonishing accuracy the bounce of 10 different balls that I dropped from the same height. The scientific method was totally in the house. Got a winner. The top 4 performers were the 2 bouncy balls, the Spalding, and the tennis ball. I have 4 balls here, 4 good and loyal friends. And I hate to choose between all of them. But as of right now, my 2 finalists are Big Bouncy and Big Pinky. This guy I'm okay with losing because I've realized it's kind of a novelty.
Yeah.
This one only escapes novelty because it's achieving an actual usable size.
Right.
You cannot complete a circuit with a bouncy ball smaller than this ball. I want to be like, bonk,
Right.
bing, bonk, whoop, pop, back in my hand.
Just the act of throwing, you put spin on it, and depending upon how it leaves your hand, that spin could be different. So by the time it comes back to your hand, there's all of these unpredictable variability that has entered into the equation.
But look, when I throw this, it's predictable. Good looking out, Corey. If you want to complete a circuit or engage in social activity, go with a hollow rubber ball. If you want a ball that bounces so much you don't care if you never see it again, choose a solid rubber ball. This is how I'm gonna say goodbye to this ball. I'm gonna bounce it off the ground and into that hole in the ceiling, and I'm never gonna see it again. Ready? Goodbye, old friend.
Oh my God. One more time with meaning. Goodbye, my old friend.
Coming up, I find a Civil War coin worth $300,000 in a storage locker. Just kidding, I'm just gonna bounce a bunch of balls. If I'm gonna get that ball to bounce off 5 walls off one throw, I need to learn how to throw, for real. This is Kevin Darlington. Guess what he does for the U.S. national cricket team? He throws balls. Once Americans start playing cricket, will we be the greatest cricket players who've ever lived?
Anything that Americans put their heart into normally comes out to be very successful.
You should run for president. Kevin is a bowler, which is like being a pitcher in baseball, except in cricket, the ball has to bounce before it reaches the batter. So Kevin is all about accuracy and bouncing balls, which means I'm all about Kevin. What's this guy running down the middle?
That's the seam of the ball.
And why is that important for throwing it?
For bowling it,
I'm sorry, you know what? I gotta learn my vocabulary. You're right, for bowling it.
it's important for you to get the grip correctly. You can either use spin, seam, or a swing of the ball.
So what I wanna do is throw a ball and bounce it in a very predictable way. I don't wanna have any surprises. How can I throw it so that it doesn't go off to either side and it just goes boo, straight, like a laser?
When bowling the ball and you do not want it to deviate, you hold it across the seam.
Right.
I hold it the same way, grip it the same way, like this. And you try and aim at your target using your lead arm.
Ah, so you aim with this one.
That's
and then,
if I'm throwing. But if I'm bowling, you try to get as high as possible.
because you're kind of throwing down.
Because it's an onwards motion.
Use your non-throwing arm to guide the trajectory of your ball. Good news! I'm one of the best throwers on the planet right now. Next step, planning out all the points of my bounce. I needed a trajectory coach. This is professional pool player and nickname haver Tony Robles. Oh, what's his nickname? Nothing much, just the silent assassin. I need to learn how to calculate where a ball's gonna bounce so that it goes exactly where I want it to go.
Right.
How do you do that?
You have to really practice bank shots a lot to try to figure out how the diamonds connect. These are what we call diamonds.
I thought this was just some kind of weird decoration.
No, they're actually used to measure angles sometimes.
Here we go.
Yeah.
Teach me.
If I know right here, the center of the lip of the pocket to the midpoint between these two diamonds, the first and the second diamond on the long rail, that will take you into that corner pocket. Why? Because the same angle in usually equals the same angle out. That's how it works. This is what we call shooting through the diamond.
Beyond it.
Right, so exactly. So once you pick that midpoint, right, if the ball's anywhere near that line, all you do is hit it dead on, and it'll equal same angle in and same angle out. That's how you calculate that.
Do you think you can make this shot?
Yeah, I have the spot.
Let's see.
Right?
You totally did it. You won the tournament. Map out your flight path before attempting your bounce. Oh. Up next, ultra-long shoelaces, balls, and frustration. Just another Saturday night. Remember this? It's time to map it out in the real world, in this room, using everything I learned from the silent assassin. I'm about to rock this protractor to the edge of destruction. And then I'm gonna use this string to represent my ball's flight path, and then I'm gonna throw the ball, and it's gonna follow the string, and it's gonna be incredible, and we're all gonna get $100 million. The crew helped me plan out my flight path. It was working out great until I got to my producer, Brock. Brock, do those look even to you?
Yeah, still not quite. A little bit more.
For angle in, angle out, it has to be like this?
Yeah.
We just made a square. That's not gonna work because with angle in, angle out, the angle in is very different from the angle out. In order for it to work, I had to reduce my bounce pattern from a 5-wall to a 3-wall circuit, or else angle in, angle out, we're gonna have my ass. This episode is about 30 seconds away from being over, so you have a little bonus free time. You can watch some of Esquire's other great content. Oh. Sorry, Brock. So I did it, and then I figured everything would be right? And everyone who's mad at me for hitting Brock with the ball, maybe he shouldn't have taped his hand to the wall by accident. Once it gets about right here, it starts falling. If I have to go learn about gravity, I'm gonna be pissed. This is Dr. Matt Kleben, a theoretical physicist from New York University. Are you the type of person who can explain to me what gravity is?
I can do my best.
If you do your best, will I understand gravity?
No, probably not.
Matt's first attempt to explain gravity involved this giant vacuum tube with a heavy coin and a light feather inside. You'll notice that the coin and the feather are both now stuck at the top of our tube.
That's right.
And what's doing that? Anti-gravity?
Static electricity. It's basically rubbing a balloon on your head and then sticking it up there.
Does this prove that static electricity is more powerful than gravity?
It's much more powerful than gravity. So I'm gonna flip the switch, and that's gonna discharge that static, and, well, we'll see what we see. Ready?
Yep.
See that?
Yeah. Did everybody see that?
They landed on the bottom of the tube at the same time. And what that means is that gravity acts on everything the same way.
I'm trying to choose my words carefully here so I do not upset the almighty gravity. What kind of punk-ass force is gravity if it doesn't even have the sense to make a heavy thing fall more quickly?
That's the question Einstein asked. And the answer he came up with is really interesting. Gravity's not a force, it's just geometry. Space is curved. And things that you think are falling are actually moving in straight lines.
I was beginning to suspect that explaining the ontology and mechanics of gravity might not be possible in a 2-minute TV segment. But Matt refused to give up. He said, "Ooh, I simply must share another of my demonstrations with you. In this one, a rubber sheet represents the fabric of space and time." I said, "Matt, what the fuck are you talking about?"
You're gonna take this ball bearing,
Yes.
and you're gonna give it a little push.
All right.
Not towards that ball, but parallel to it, like along in this direction.
All right, ready?
Be gentle. And the reason it's orbiting around it is because the rubber sheet is curved.
So what did we learn?
Objects move in curved lines on curved surfaces. If this was flat,
Right.
if this had just been the tabletop and you did this, the ball bearing would just fall off the edge of the table.
It would move in a straight line until it fell off the edge of the table.
That's right.
Right. Okay. I think I finally might understand what you're talking about. So I grew up thinking that gravity was in the Earth's core, like a magnet that just pulled everything down there. But on a super tiny level, any object with any mass is producing gravity. Is that true?
That's true.
Because any object of any mass is bending space-time.
That's right.
And if you've curved space-time, that curved line is what everything will follow. which is why everything would fall at the same rate because they're all following the same line.
That's exactly right.
Now I'm starting to feel like the popular understanding of gravity is actually kind of misleading.
Yeah, I'd say more than kind of. Yeah.
You know what? Talk to the camera. Tell Americans right now what they need to do to get a better understanding of gravity. I'm not kidding.
Get a PhD in physics. It's a lot of fun.
Okay, back to our show. Next, Matt had some practical suggestions on how to keep gravity from making ball bouncing so annoying.
I'd say the best way to overcome your problem with ball bouncing would be to go up in the space shuttle and orbit around the Earth.
Corey, book us a flight on the space shuttle tomorrow morning, 10:30 a.m. Until that flight on the space shuttle, which is definitely gonna happen, let's talk about next best options.
You can throw the ball a bit up in the air. Gravity's still gonna pull the ball down.
Right.
But if you throw it up in the air, it'll take longer for it to pull it back down to the ground.
I'm buying time to deal with the effects of the space-time curvature.
That's right.
Okay.
Yes.
Our grand finale is moments away. Can a grown man bounce a ball? Did it! Was that it? So at this point in the episode, I've got two scientists from American universities telling me the way I want to bounce a ball is either going to be difficult or impossible. I didn't sign up for difficult or impossible. Bouncing a ball is supposed to be fun. Where are the scientists who can teach me how to have fun? I visited the Play Science Lab where Dr. Allison Bryant and her Play posse study the neuroscience of something called play.
We talk about the play spectrum, and that's how closed the play is or how open the play is. So open play is completely unstructured. There's no rules. You've got a cardboard box. You're just kind of creating and making a fort, right?
Yeah.
Now, if you then bring your figurine from whatever your favorite movie is, and you
Right.
bring it,
Grey
and
Garden.
you start imposing some of the story structure, then you're starting to close your play a little bit.
Allison and Paul hooked me up to all kinds of electrodes to measure super tiny movements in my face, my heart rate, and my skin conductance. And my skin conductance was slamming.
All right, let's do some science.
I'm ready to do some science and have some fun doing science. They gave me a variety of closed and open tasks to perform. Some were timed with lots of rules, and others were totally up to me.
You're gonna have 1 minute, and you need to build me the Leaning Tower of Pisa.
You can't expect me to do this in 1 minute.
This time, just build whatever comes to mind.
Oh, Danny boy, the pipes are calling. Are you having fun, boy? Are you relaxed, boy?
So what you see is when you were structured, there was a lot of concentration going on. This was a lot of effort. Also pretty negative. Your positive kept getting lower and lower as you got more frustrated. Now we were playing with the bricks. You had a couple of little negatives.
I know what that was. That's when it broke.
That's what it broke.
But what were you measuring right here?
This is
My eye muscles?
No. This is your frown. Imperceptibly, you were frowning. You were frowning on the inside. Literally.
You don't even know.
This to me is the most interesting one. First of all, look at this. It was like there was no effort.
There's something wrong with the machine. I would have had to put effort in that to make that song happen. I sincerely thought there had been some kind of mechanical malfunction. I said, Paul, get in here. Paul, we're looking at this data, free play guitar, and I've got concentration down at 0. And this makes me think a sensor fell off because I was concentrating. I was trying to play chords and make a song.
I think you were concentrating at a conscious level, but remember these measures are picking up unconscious responses that your brain is engaging in. That's why we see the flat line there. It's very relaxing. You're in a flow state.
You're saying that it's not that this machine broke. It's that I actually enjoy playing guitar.
It's clear that free playing guitar is a relaxing, happy place for you. Remember, my mad science machines never break.
Okay, that took me to my happy place. This whole episode, I've been meeting with physicists and anthropologists and all sorts of freaks and weirdos to make ball bouncing second nature and therefore become fun, like open-ended, unstructured play. Have I gotten that good? Am I going to enjoy bouncing a ball? Let's find out. It's time to bounce a ball. Choose a room that has no obstacles for bouncing or catching your ball. Choose a hollow, vulcanized rubber ball for maximum throw ability, catchability, and bounceability. Map out your flight path to help with aim and trajectory. Remember conservation of angles. Angle in equals angle out. When attempting your throw, create enough thrust to overcome gravity. For optimum results, treat ball bouncing as play rather than work. Goodbye, my old friend. Hello, my friend. My goal for this test is to bounce the ball off 3 walls and then catch it without having to move. My first step, identify the best ball for these squash court walls. Handball is going to get me closer to coefficient of restitution of 1, which is what I'm looking for. Ball test time. Nope. Whoops. I'm going to bring it out, try to hit it farther away from the corner. Watch what happens. Son. I adjusted the angles in my mind, and it paid off. Boom! That's what I'm talking about. You're looking at a man who's having fun bouncing a ball. He's proficient enough to know the techniques and strategies to get what he wants, but he's also keeping it loosey-goosey. I did. I bounced a ball. It was amazing. Do you agree that backwards time travel is just a bunch of Hollywood bullshit that'll never happen?
Yeah, it's all bullshit.
Yeah. Thank you.
You're welcome.
Thank you.